In this video, we're going to begin to take a look at the unit circle, which is one of the primary topics that we discuss in trigonometry and that you'll continue to see as you move through higher level mathematics like calculus and differential equations and so forth. And so I want to begin in this video to look at how to define the 6 trigonometric functions as it relates to the unit circle. A couple of things I want to point out. We've been focusing on the definitions of the trigonometric functions as they relate to right triangles. And one of the challenges with right triangle trigonometry is that you're limited to acute angles, which measure somewhere between 0 and 90 degrees. And because of that fact, we only end up with positive trigonometric values. And we talked about that previously. Also, typically when we're dealing with right triangles, we deal with measurement in terms of degrees as opposed to radians. So right triangle trigonometry uses mainly degree measurement, which most people are familiar with. But as we move into the discussion of the unit circle tends to use primarily radian measure, which most people are not as familiar with, but radian measure is used extensively in calculus because it's a little bit easier to deal with than degree measure. One of the benefits of the unit circle is we can expand our definition of the trigonometric functions to specific angles that are between 0 degrees and 360 degrees, which is a full revolution around a circle, or between 0 and 2 pi, if you think about it in terms of radians. So the definition, what is a unit circle? If we're going to talk about it, what is it? The unit circle is a circle with a radius of 1 with its center at the origin of a rectangular coordinate system. So let me see if I can kind of sketch you a rough picture. Now you may remember that for a circle, okay, just a kind of a quick review thing here, really the formula for a circle is x minus h squared plus y minus k squared equals the radius squared, where h and k correspond to the center of the circle and r represents the radius. Now, first of all, let me remind you that the radius goes halfway across the circle. So if we had a coordinate plane, which hopefully you're familiar with, okay, and I'm going to mark where my 1 unit would be roughly, okay, our center of the circle would be on the origin, which has the ordered pairs 0, 0. So my h and k are 0, and then my radius goes from the center out to a value of 1 in every direction. Now, it's a little bit hard for me to draw that in every direction. So roughly, and again, this is a very rough sketch of a circle, okay, this would be your circle. So if you plug that in, how do we end up with x squared plus y squared equals 1? Because you would have x minus 0 squared plus y minus 0 squared equals 1 squared. And we don't typically write the zeros in there, so we would have x squared plus y squared equals 1. So there is the formula for the unit circle and how it is derived. So now I want to think about defining the 6 trigonometric functions in terms of the unit circle. And to do that, I want to draw a triangle onto our unit circle. So here we have a unit circle, okay? So our origin is at the center, which is 0, 0. Okay, and we have a radius of 1. So I'm going to draw out a radius. See, and the radius goes from the center to a point on the circle. So this is my radius, which has a length of 1. And so then if I rough sketch in a right triangle. Okay, so there's my right triangle. Remember from good old basic algebra that the distance traveled horizontally is represented by x, and the distance represented vertically is your y. And so typically this point here where we intersect the circle would be an ordered pair xy. But let's think about it in terms of the unit of the right triangle. So if this angle here, which is in standard position, where we start on the positive x-axis and rotate, and we're going to call this angle T. Now we could use theta or whatever. So if we think about that and think about our definitions of our trig functions, let's think about what we would have. The sine of angle T is the opposite over the hypotenuse. Now again, think about it here in terms of your triangle. Next to T, the adjacent side is the x, the opposite side is the y, and the radius represents our hypotenuse. Okay, so if I plug those values in, I have y, which is the opposite side, over hypotenuse of 1. So the sine of t corresponds to the y coordinate of the ordered pair. So now we can look at it as an angle and end up with a real numeric value. Okay, now let's think about cosine. The cosine of angle T would be adjacent over the hypotenuse, which gives us x over a hypotenuse of 1, which is x. So now our ordered pair, which we are traditionally view as x comma y in terms of our trig function, can be written as the cosine of the angle, sine of the angle. Okay, so our ordered pair x comma y becomes cosine comma sine. And then the third one that we have there, that we use a lot, is the tangent. So the tangent of angle T is opposite over adjacent, which would give us y divided by x. Now we do have to have a caveat here that x cannot be 0, because you cannot have 0 in the denominator of a fraction. So the ratio of y to x becomes our tangent. And those are the three most common ones. So we have the sine of angle T corresponds to the y coordinate of the ordered pair. Cosine of angle T corresponds to the x coordinate of the ordered pair. The tangent is the ratio of y over x. And then remember, this second column, they're the reciprocals. Okay, so for sine, the reciprocal is cosecant. And so we basically would flip it over. So we have the cosecant of angle T is 1 over y. Now here again, you do need to realize that we have the little caveat that y cannot be 0, again, because you cannot have 0 in the denominator of a fraction. And we had that for the tangent, that x could not be 0. Similarly for the secant, which is the reciprocal of cosine, we flip over the x. so that we have 1 over x is equal to the secant of t. And again, we need the little restriction that x cannot be 0 because you can't have 0 in the denominator of a fraction. And then cotangent is the reciprocal of the tangent. So we flip it over and it becomes x over y, which is the cotangent of t. And again, we do have to have the restriction that y cannot be 0. So that gives us our 6 basic trigonometric functions in terms of an ordered pair or in terms of real numbers. Now we're going to look at some special angles on the unit circle in the next video.